professors, and thank you very much for joining me for this comprehensive viva. My name is Kosi Emmanuel Chukwujindu, and I'm going to make a presentation of the progress I've made so far with my coursework and proposal for my research. Before I commence, please, I want to confirm that my screen is visible to everyone.
Yes, you can. Yes.
So the title of my research proposal is Evaluation of Optimal Height Threshold for Energy Efficiency and Passive Thermal Comfort in Tropical High-Rise Dwellings. My name is Chukwujindu, Kosi Emmanuel, and I am a research scholar at the School of Architecture and Interior Design, SRM Institute of Science and Technology, Kadankulato. I'm being guided by Dr. G. Kasiraman from Mechanical Department and Ma'am Dr. Niha Bansal from Architecture Department. This slide contains my personal details, bio, and professional progress. So for this presentation, the presentation outline is thus. I'm going to speak first about the introduction to the topic which I have chosen. Then I'm going to touch on the statement of the research problem. What is the problem which I had the research problem for which I'm trying to create a solution. And then I'm going to go through the literature which I had reviewed, review of published literature which I had conducted. And I'm going to identify the aim and the objectives of this present study. And I'm going to highlight what are the research questions which this study will answer if it is completed, when it is completed. And then I'm going to mention the research hypotheses which have been formulated to guide the study. And again, I'm going to point out the methodology which I had identified for this particular study. And also I'm going to justify the choice of that research methodology. And then I'm going to move on to mention the research process. What is the process which this research is intending to take? And then the list of experiments which will be conducted and what are the expected results. And I'm also going to highlight the progress which I have made so far. And that will include what courseworks I have completed. And I'm going to also be mentioning what the timetable for the rest of the work from this moment onward is, and what publications I have done, and also the okay. So yeah, the last one says the workshops attended and the references to this study. So I start here with the introduction. So by means of introduction, I have taken a little, I have made some bullet points to highlight how did high-rise buildings come into place? What are the benefits? High-rise buildings is a building typology which has been around for a while. It has a number of benefits. And actually, in terms of the history of high-rise buildings, it came about in Chicago, where because of the newfound technology of steel after the Great Fire had consumed Chicago, so they were shifting from wood and mortar to steel construction, and they found that with this new technology they could stack up more floors. And as this continued to happen, we've seen series of high-rise buildings emanate from different countries over the years, and it has some benefits which include it saves land. So instead of building horizontally, taking up a lot of horizontal land, you just stack up in one plot and you save a lot of land, especially in urban areas where land is very expensive. Then it also has ecological conservation benefits in the sense that instead of destroying a lot of flora and fauna to build, you save those and you build in a small area, and instead you stack up vertically. So we also talk about the mixed use advantages. A single high-rise building can house commercial, it can house residential, it can house office use. So this kind of mixed use advantage saves costs, and it saves the energy required to do different buildings for these different uses. So we also talked about the symbol of authority and technological advancement. Like I had mentioned, the technological advancement in the discovery of steel and the composite construction method has helped developed countries and developing countries to build taller and taller. And today, the tall buildings like the Burj Arab, the lot of tall buildings like the buildings by Kenyang, they stand as, like the Taipei 101, they stand as symbols of authority in the cities that house them. So this is also an advantage. Then it also, high-rise buildings also improve the socioeconomic value of surrounding properties. So in capital cities where you have lots of high-rise buildings, you find that other properties around those high-rise buildings tend to appreciate in value because it is seen as a highbrow area, and it is usually targeted for the high-income earners. So other advantages include less noise for occupants in the higher floors. Yes, because the hustle and bustle of the city happens at the ground level, at most the road level. But when you live in tall buildings or when you walk in a tall building, beyond a certain height, you are immune from the noise at the lower levels. So this could also be considered as an advantage. Aside the unobstructed scenic views, you can have great views from higher levels, and also you can have a feeling of exclusive living, etc. So also as a means of introduction, I've prepared this chart or graph, which is showing the high-rise building starting from 1885, the home insurance building in Chicago, and I have traced the the increase in height of high-rise buildings over the years, and I have mentioned the names of the buildings and the heights also. So we can trace this progress from the home insurance building in Chicago up to the Burj Arab in Dubai. So yeah, that's also what we're trying to show here. And then one important thing at this point is to identify what is the definition of the high-rise building by NPORIS. NPORIS is the World Authority on High-Rise Buildings. It is it's from the Council for Tall Buildings and Urban Heritage. So they have defined a high-rise building as a structure whose architectural height is between 35 and 100 meters, or if it exceeds 12 suspended floors, it can be regarded as a high-rise building. So now I've mentioned the history of high-rise buildings. I've talked about the benefits. Now I'm also trying to highlight what are the challenges associated with this building typology. So of course, we know that with increase in height, tall buildings become more resource intensive due to the excessive scale and complexity required to achieve them. Heavy energy and heat supply is required. Again, you have to worry about the unstable wind pressures, and you have to rely on technology to fight fire at such altitudes. Also, the problem of vertical transportation, you have to make sure that you have steady power supply, otherwise you cannot travel to upper floors without lifts. And if there is no power, the lifts won't work. And if the lifts don't work, you have a building which is non-functional. This also goes for water supply. Pumping water from ground level to higher levels needs a lot of energy to do that, and specialized technology. Again, I highlighted that it requires highly skilled consultants and contractors to design and build, because any wrong design strategy can lead to increase in energy consumption. So I have included this pie chart from interpreted from the United States Department of Energy reference building, where they have tried to identify in percentages the different aspects of energy consumed in high-rise buildings. And we can see that the highest energy consuming feature is the heating and cooling energy, which has 33%. So this points us to the fact that heating and cooling, which we also call as HVAC, is a critical area when it comes to high-rise buildings, and it's one of the challenges that high-rise buildings currently face. Then again, this report by the United Nations, global reports, in a more global sense, has highlighted the fact that buildings generally, whether high-rise or low-rise or medium-rise, consume 36% of natural resources and energy. So it means that the construction and operation of buildings consume 36% of the world energy consumption and generates 39% of the world's greenhouse gases footprint. So we cannot neglect this, because it's important for us to identify why is it that these buildings are consuming so much energy. And of course, lots of researchers have worked on this, and there's a move towards reducing the energy consumed by buildings, especially high-rise buildings. So in this slide, I have gone ahead to state what is the research problem that this whole topic is trying to address. I have put it like bullet points, which the height of tall buildings thus far chosen arbitrarily. Tall buildings consume a lot of energy, as I have mentioned, especially due to HVAC load. Then the increase in height, the number of floors, poses additional HVAC load, especially in residential tall buildings. And then there is currently no height threshold for passive thermal comfort and HVAC energy efficiency in residential buildings. So we went into a review of published literature, and a number of them also have done a lot of work, extensive work in the area of energy efficiency, thermal comfort, and high-rise buildings. So this particular study by the Council for Tall Building and Urban Heritage, I'm referring to the picture by the left with red arrows pointing at item number 2. So they had conducted a study, and they had identified major topics that are of importance as far as high-rise buildings are concerned. And the number 2, the second on the list, according to their report, was that there was need to research to determine the optimum height, density, and massing of tall buildings in order to provide appropriate social interaction and communities at an urban city scale. So this particular work by the CTBUH identified this as a gap which needs to be studied, which needs to be researched. And to the right, you can find that the researchers at University College London in 2017, they had also done some work, and where they had taken some high-rise buildings, and they had analyzed the energy consumption. And the high-rise buildings which they took, by the way, were commercial office high-rise buildings. So they had come up with this conclusion in their report, that they found that beyond the certain height, the buildings begin to become energy inefficient. Like it's not efficient to build beyond that height. So now we went forward to look at the definition of the key concepts which we are talking about, which include energy efficiency, thermal comfort, and building height. So simply put, energy efficiency means using less energy to get the same job done, and in the process, cutting energy bills and reducing pollution. So in this case, we are focusing on energy consumed specifically by heating, ventilation, and air conditioning. So we're talking about the thermal comfort. Thermal comfort is defined as the condition of human mind that expresses satisfaction with thermal environment and is assessed by subjective evaluation. The building height refers to the vertical distance from the grade level at the main entrance to the top of the parapet that comprises the majority of the building for a flat roof. So basically what we are looking at is 3 things: energy consumed by HVAC, the thermal comfort of the individuals who are in these buildings at different altitudes. So I had come up with this graphical illustration to explain what I think the relationship is between these three elements. So energy efficiency, or what you can call energy consumption. So whatever energy is consumed by HVAC equipment is consumed because they were used to provide ventilation and thermal comfort for the occupants. And so if we want to affect or reduce or increase the energy consumption, we have to alter the design of the buildings. So we have to use passive design strategies. And if we're able to do that, you can see the arrows go back and forth. So whatever you change to the right will affect to the left. That is what I'm trying to explain with this figure. And at the bottom of it, I had put a statement that says that height is an important design parameter, because if you're going to alter the design of the building, height is a design parameter as well, because it has to do with altitude. And we have to find out whether this influences ventilation or thermal comfort, because if it does, then of course it will influence HVAC use. And if HVAC use is influenced, then energy consumption will be influenced as well. And we can then decide whether the energy consumption is reduced or increased. So that is what I'm talking about with this slide. Then further on in this section, I had also reviewed more literature. This is also another work done by Davis Langdon, where they had taken a high-rise building and they had looked at the different aspects, such as the refuse strategy, the servicing strategy, the vertical circulation, the structural solution. And they found that after every average of 10 stories, these different aspects tended to reduce inefficiency. So this is also important for us to note that something is going on as height is increasing. So building efficiency in various aspects was seen to drop by an average of 10% after every 10 floors. So this immediately strikes up some questions. To what extent does increase in height affect energy use? And how does this relate to the thermal comfort of the occupants? If there is such an influence, is it the same across different climatic regions? And is it the same for high-rise residential? Is it the same for high-rise office buildings and commercial buildings? And then what are the implications for the future? What are the implications of this for the future of high-rise buildings? Move on to the next part, where I highlighted the work by the popular patron of bioclimatic design concepts, Ken Yang. So the principle of bioclimatism, which simply means design aiming at the construction of buildings that are in harmony with the natural surroundings and the local climate, ensuring satisfactory conditions of thermal comfort inside. So Ken Yang has, over the course of his practice life and academic pursuit as well, he had written lots of books, lots of articles talking about the principle of bioclimatism, and he himself had done lots of designs, lots of real-life built buildings, tall buildings, where he had tried out this concept. So again, this immediately strikes up another question. If it is possible to design high-rise buildings to adopt the bioclimatic concept, is this same? Can this be true at any height at all? Or at a height it's impossible to have a bioclimatic skyscraper. So this is a missing link that has been identified from this particular study. Further sorting and processing of the reviewed works, where I have displayed them here in form of graphs and charts so that it's easy to understand. In this, I am trying to show the dates, distribution of the articles reviewed according to the dates. In this, I'm trying to show the distribution of the articles according to the research methodology applied by the authors. In this, I'm trying to show, same. I've just made it like a chart. So it's easy to see what research methods the different authors that have worked in similar research areas had adopted. So we find that the most commonly used methodologies were the field measurement and the statistical analysis and energy modeling using variety of simulation software. GIS and remote sensing technique was the least commonly used, as we can see from this chart. So I also made this chart to show the distribution of the articles studied according to the climatic zone where the tall buildings that were studied were situated. So we find that the tropical climate has seen the most studies in this regard. The results reveal that the tropical climate has seen a higher number of publications in the field of thermal comfort, energy use, and building height, followed by the temperate climate and continental dry, as you can see. So it's easy for us to understand what is going on in terms of research in this area. We have also prepared this distribution by the type of use. I had mentioned earlier that it is important to know whether this influence of height is different for residential, commercial, and office buildings. So the articles which have been reviewed so far, we found that most of the study was done. The results of the statistical study revealed that majority of research studies were carried out on mixed use type of high-rise buildings. So this is also important for us to know what is going on and what other researchers are doing in this field. Then this shows the distribution according to the objective of the research, why those authors had carried out this research. So studies focused on testing the influence of architectural or structural design parameters such as height, form, orientation, facade material, etc. on thermal comfort and energy use was found to have the highest frequency of occurrence, as we can see from this chart. More work had been done in this area, the area where the objective of the researcher was to test the influence of architectural design parameters, which includes height, on the energy and thermal comfort of high-rise buildings. So in summary, we identified some gaps. I've mentioned that the gaps identified in the literature study include that there is no definite height threshold for energy efficiency in residential high-rise buildings. There is no knowledge so far on the nature of the influence of height on thermal comfort in high-rise residential buildings. There's also no knowledge on the comparison of HVAC energy performance between residential and commercial high-rise buildings, which means we don't know so far whether residential high-rise buildings are consuming more HVAC load than compared to the commercial high-rise buildings. Also, we found that there is paucity of research on tall buildings from Africa. And finally, we found that there's no knowledge on the relationship between building use and thermal comfort. So now this brought us up, now because of that, we came up with the aim and objective of this very study, which is to evaluate the relationship between these three elements of building height, passive thermal comfort, and HVAC energy consumption. And we are talking about specifically the residential high-rise building. And it is with a view to ascertain in empirical terms the optimal height or optimal height threshold for HVAC energy efficiency and passive thermal comfort in high-rise buildings. So what this means is that we're trying to study three variables, which is building height, passive thermal comfort, and HVAC consumption, low energy consumption. And we're trying to find if there is a relationship between these three, and if so, what is that relationship in empirical terms? That is the aim of this study. And the research questions that this study will answer, when it is completed, we had identified four main research questions. The first one, we want to find out if there is a significant relationship between the building height, which means the altitude, the floor level, and the HVAC, and the energy consumed by HVAC equipment in residential high-rise. We want to find out if there is any relationship at all. Secondly, we want to find out if there is a significant relationship between the floor level and the occupant's passive thermal comfort, which means if I am on the 50th floor and someone else is on the 13th floor, and suppose there is no HVAC equipment at all installed, we want to test if there is a relationship between, we want to test if there's a difference or if there's a relationship between the feeling, the thermal comfort feeling of occupants at different floor levels. Then thirdly, we want to know what is the nature of this relationship, if it exists. And fourthly, we want to check, by the time we answer these three questions, we will come to be able to find out if there is a range of floor level within which it is optimal to maintain low energy consumption and passive thermal comfort. So these are the questions which this research intends to answer. And to answer that, we have formulated, using the alternative hypothesis method, we have come up with 4 intelligent guesses, which will be subjected to testing and adoption or rejection. So for the first question, we have tried to say that there could be such a relationship. In the second question, we have tried to say, yes, there could also be such a relationship. In the third question, we have also said, yes, we think there is such a relationship between these 3 elements. And then for the fourth question, we are making a guess, an intelligent guess, that there must be an optimal height range within which, if you maintain that height, if you do not just design your building to any height of your choice arbitrarily, if you maintain this certain height range, you can achieve passive thermal comfort and you use the minimal energy consumption. So this is an intelligent guess, 4 intelligent guesses to answer the 4 questions. And these guesses are going to be either accepted or rejected at the end of the study. And for the method which we intend to use for this study, it's going to basically field work data collection. We're going to use a formula to arrive at the number of buildings which we're going to study. And then we're going to visit those buildings and we're going to take measurements on ground for calculating the thermal comfort. As for the occupants' thermal sensation, that is how they think they feel in the buildings, we are going to issue a structured questionnaire to capture that. And then we're going to, the reliability of the instruments which will be used, we're going to use the test-retest method and Krobach's alpha to establish the coefficient of reliability of their responses. So that will make sure that they don't respond due to bias or they don't respond due to some other physiological or psychological imbalance at the moment. And then we are as per the energy consumption due to HVAC, we're going to try to abstract that from the energy bill, energy data, the EB. So we're going to be requesting that for the different apartments at the different levels. And we're going to use mathematics to abstract exactly what amount of that consumed energy was due to the HVAC, air conditioners, and all. So once we have this data in tables, we're going to now we're going to now simulate. So we cannot, for some buildings where we use this CFD simulation software to test for HVAC performance beyond heights where we are not able to reach. And then we're also going to use the IES VE and Energy Plus software to model the loads in the virtual environment and apply the different responses from the occupants at the different heights and watch what happens to the energy and what happens to the thermal comfort at the different levels. So at the end of this, we are trying to collect data with the aim to clarify the patterns of relationship between 3 variables, which I had mentioned, which include the floor level, the passive thermal comfort at different floor levels, and the energy consumed by HVAC at different floor levels. So the area of the study for the area identified for this study is Lagos, Nigeria, which is my home country. So as a justification for the choice of the research methodology, we had mentioned that CFD and ISVE simulation is industry standard for simulating HVAC performance in yet to be built spaces. So many researchers have used the CFD simulation. There are lots of work that have stated that this is the method they use and they arrived at reliable results. So energy, again, as for why we are using EB, energy data collected by the Municipal Electricity Board is the most reliable because it's the government authority that issues and measures, calculates and collects energy bills. So it's reliable. Whatever data they provide for this study at the different levels will be very reliable. That is why we have chosen them. And then for the thermal comfort calculation, there is a wonderful tool which was developed by the CB, University Berkeley, where they are the screenshot shows an interface of the software. So all you have to do is to grab the real life measurements, and then once you put it in this software, it gives you the thermal comfort at every level. So we had also prepared a chart where we compared the methodology which was used by other researchers, and it is here in Excel. The other researchers had used different methodologies, and I had mentioned this in the previous slide. So I'll just come back to this one. So as for the research process, we're going to use, I have mentioned that we're going to be doing a lot of field data collection, but before that, we have to identify the instruments that will be used, which have been identified, and we have to test and validate them before we hit the field. Once we are in the field, we grab the measurements and issue this questionnaire, the structured questionnaire, and also get hold of whatever secondary data is available. And once we come back from the field, we put this down in tabular format, and then we try to iterate using software to see what happens in cases where we go higher, and we'll try to iterate the different values, and then we'll present this in tabular format and perform statistical analysis. And then we will be able to accept or reject the hypothesis. Yeah, as for the, this is also mentioning about the three elements which we are talking about, which include HVAC energy consumption, the occupant's thermal sensation volt, and the floor levels, the floor heights. So this is the list of experiments which will be performed. We're going to, I had mentioned that we're going to use the Taro-Yamane formula to arrive at the sample size, and then we're going to use structured questionnaire to grab the occupant's thermal sensation volt, and then we're going to use Hobo sensor equipment HD32 instrument to grab the 4 parameters which make up the thermal comfort, which include air temperature, relative humidity, air speed, and mean radiant temperature. So once those are captured, we're going to use the CBE thermal comfort calculator developed in Berkeley to calculate and arrive at the thermal comfort for the different levels. And we're also going to use CFD simulation. We're also going to use the Energy Plus software. Once that is done, to analyze the results and come up with significant relationships or correlations or regressional analysis, we're going to employ the use of the statistical package SPSS. And then to present our finished works, we're going to use Excel, PowerPoint, and Word. So at the end of this study, it is expected that we will find, one, whether there is any relationship at all within these 3 variables, and if so, whether it can be expressed in a mathematical formula. And if so, it is expected that this relationship, once captured in a mathematical form, can be applied for various uses, like future designers, future architects can use this to determine whether they want to go to 100 floors, whether they want to go to 200 floors. It will no longer be arbitrary. It will now be guided by some form of mathematical expression between energy consumed due to HVAC, floor level, and thermal comfort. If such a relationship exists, we're going to find out. So the progress which I've made so far with this work is that I have sat for and completed 6 recommended courses, which are given in this table. The first one is the research methodology course, where we talked about the actual procedure a research is supposed to follow. As for the research and publication ethics, we touched on what are acceptable and what is wrong when it comes to research and publication. Then, as for the internal courses which we did in the department, I took 4 internal department courses, which include facade technologies, green building strategies, performance evaluation tools, and new age materials and methods. So I also published 2 academic papers during the course of this PhD work. I had also conducted one of these papers was a pilot study which was conducted in my home country, Nigeria. And then the research methodology had been decided. The equipment which I will use for this study has also been identified, and the study area has also been identified. So going forward, this timetable is meant to guide my work from now, because I am now in the, I'm officially like at the end of my 3rd semester, I'm going into my 4th semester. So from this 4th semester, I'm supposed to do the field work, data collection. It's supposed to take the whole of the semester basically. And then I'm also going to do, try and attend more conferences. And, by the time I'm done with my field work, once I come back, I go into the data sorting, analysis, the laboratory work, experimentation, simulation, testing. I'll try to publish my results as I move on and then attend more conferences. So this is details of the papers which have been published and where they were published. And these are details of the conferences and workshops which I had attended during the course of my PhD work. That is it for now. Thank you very much, professors, for listening. I'll appreciate your feedback. Thank you.
I welcome our expert members to interact with the research scholar.
Okay, Mr. Emmanuel.
Yes, sir.
I like your presentation. I think very systematic and well-organized presentation.
Thank you very much, sir.
And within a year, I think I've published 2 papers also. It's really a very remarkable one.
Thank you very much, sir.
Good work. So, I think in many of the literature, I think they talk about all that height, then the relation between that height and the energy efficiency, then passive design techniques, everything already they talk about. What is the novelty in your project? Already it was discussed in many of the literature. Hello?
Yes, sir, I'm with you. I'm trying to, your audio is a little bit wavy. I didn't get your question.
No, can you hear me now?
Yes, I can hear you now, sir.
Yeah, that many of the literature already they discussed about that height and that energy efficiency and passive design techniques, all that they already discussed. So you are only repeating what is the novelty in that?
Okay, the novelty in this particular research proposal is that as at now, the academia, the body of academics does not know for sure what is the optimal height. As it stands now, high-rise buildings are done arbitrarily. You have more money, you can go to 1,000 floors. I have less money, I can do only 10 floors. There is no known scientific range of height that is optimal for maintaining passive thermal comfort and low energy consumption. So if this study finds that out, it will be a very new and wonderful information, because now it will guide future designers regarding height decision.
Okay. Then what is the tallest building in Nigeria? How many floors?
Oh, the tallest building in Nigeria is around, I'm not very sure about that, sir. I would not like to provide figures that I'm not sure about, but I would say around 40, 50 floors, sir.
Okay. Then what is the typology of building you are going to take? Is it a mixed use or is it what typology of building?
Sir,
you are taking?
Yes,
Building,
for this study,
yeah.
For this study, we are taking the residential high-rise buildings, sir.
Residential.
Yes, sir. Because some other researchers have done similar study for office and commercial. There is no study yet on the residential. So this study will go for that.
And what difference it will make whether it is a commercial or residential?
Yes, I think the difference will be there because the number of hours of use and the length of use, the duration of stay will vary for the office building compared to the residential building. And also the number of HVAC equipment installed for commercial and office buildings will vary from those installed for residential. And also residential high-rise buildings are more, apart from the fact that people go to work in high-rise buildings, if you live in a high-rise building and you live at such altitudes, it is very important to know whether the height is affecting your well-being, your comfort, versus when you just go to work and that's work. But this is where you live. It's important to know.
And one more last question. Can you tell some of the passive design techniques used in the tropical climate?
I'm sorry, I didn't get that, sir.
No. Can you list some of the passive design techniques used in the tropical climate?
Okay. The passive design techniques used. Oh, yeah. There are lots and lots of passive design techniques. In the first instance, the word passive design tries to provide alternative method of maintaining indoor thermal comfort without relying on HVAC equipment. So understanding this means we're talking about the window to wall ratio. We're talking about the facade materials which you use. We're talking about the building orientation, the way you position your building matters in terms of wind direction and solar path. And also we're talking about the, even in terms of providing atriums and courtyards. This also helps as a passive design technique to, it helps in stack effect. The hot air rises through the atriums, and if the atrium is open, it can leave. Therefore,
courtyard is one element. Can you tell some more elements of the passive design techniques? One element is a courtyard.
Yes,
so what are the other techniques?
I mentioned building orientation. Okay. Also, I mentioned building form. The form of a building also affects the energy, the solar heat gain, Then I also mentioned that you can alter the window to wall ratio. So you let in more light where you need more light. You let in less light where you need less light, more ventilation. You can also talk about the living, having green on the facade of the building, so that it improves the ventilation, it improves the oxygen content of the air. There are lots of technologies that can be used for passive design.
Okay, Emmanuel, then about your publications,
yes, sir.
Is it a Scopus journal? What is it type of journal? Is it a Scopus Index or the ACA?
Yes, sir.
Or is it a paid journal?
The first one is a Scopus Index Journal, and the second one is a conference proceeding.
Very nice.
This one. The Journal of the International Society for Study of Vernacular Settlements. It's Scopus Index since 2016.
Is it unpaid? No, is it unpaid journal or paid journal?
It is paid, sir. It is paid.
Okay. Better you try to publish that unpaid journals. You will have more again. That the quality of what you are presenting is really looking very interesting. So
thank you, sir.
Maybe in the future publications you look for unpaid journals.
Yes, I will do that.
Or ACA. All the best. Good
yes,
work.
Sir.
All the best.
Thank you very much, sir. Yes, ma'am.
Audible?
Yes, ma'am.
Yes. Okay. First of all, I appreciate for the amount of work you carried out within a year. And what I felt is your focus is missing, okay? Like you started with the range of buildings height within which Kenyang's principles will be effective, okay? So that was your focus. But like Sir said, there are a lot of studies which have been done with the relationship of building height and energy consumption, okay? What is your contribution in this area of research? Your focus, you said initially, based on the Kenyang's principles, what is the range of building within which this, the thermal comfort you could achieve? So that is your main objective. So you should focus on that. Like you said, window to wall ratio, all this, all those parameters are already addressed. Okay, maybe you can focus on Kenyang's principles and how, what is the relationship between the height and the, application of Kenyang's principles in terms of passive design strategies, like you said, no, incorporating green and all. Okay, so
yes, ma'am.
You should focus on that.
Yes,
rather than the regular things you showed. Okay.
Yes, ma'am.
My observation, and you need to come up with more iterations. Okay, so
okay, ma'am.
That will help you to come up with the proper solution, and there should be a holistic approach which will provide in terms of process or framework or prototype model. Okay, so the phase one, that is, you said the survey, statistical analysis, all this is fine, but the second part, the CFD simulation and all, you need to explore. I don't think IES will help in incorporating green and all. So you need to explore more simulation softwares which will study the impact of green or vegetation, which your research focus, that is the relationship between height and Kenyang's principles, will be addressed. Okay, so
yes, ma'am. Yes, ma'am.
And you could also show comparison between horizontal development and vertical development. Okay, in terms of energy, then it will be even more valid. Okay, so you said by going for vertical development, you could conserve more energy rather than the horizontal development. So you can even make a comparison of that.
Okay, ma'am. Okay, ma'am.
These are all the comments, and the publications, like Sir said, if you go for unpaid journals, you will get proper review comments, which will help you to improve your quality of work also.
Yes, ma'am.
Okay. All the best.
Thank you very much, ma'am.
Can I ask my questions? Yes,
yes, ma'am.
Okay, so yes, I agree, and it is a very systematic presentation, Kosi. So very well done on that. I have a couple of questions regarding your inquiry, what you want to really achieve at the end of this research.
Yes,
so, how do you intend, can you go to your first slide where you have the title of the research. Yeah.
Yes, ma'am.
So you say that you want to understand the optimal height threshold. So let us look at one parameter at a time. So if it is the optimal height threshold for achieving passive thermal comfort in tropical high-rise dwellings. Now, how
Yes, ma'am.
are you determining passive thermal comfort in whatever samples you are taking?
Okay. For determining the thermal comfort, ma'am, I'm using two methods. I'm going to collect actual weather information from this building.
Indoor environmental data,
Yes,
right?
ma'am. Yes, ma'am. Indoor data regarding air temperature, air speed, relative humidity, and mean radiant temperature.
Absolutely.
I'm going to collect.
Yes, and then you will check whether it falls within the thermal comfort range or not. Whether you go for adaptive or you go for the fixed one,
predicted.
Whatever it is, you will actually get whether this given set of conditions fall within thermal comfort or not. But is thermal comfort, which is whether it is there or not, whatever environmental conditions are there or not, dependent only on the height? Or there are so many other parameters which are also varying. There is building envelope. So is after going for the survey, after collecting the data, are you going for simulation? Are you going to establish a base case, which is based upon your study of the real case, and then simulate it for varying heights, and then understand whether it is giving you thermal comfort or not? If not,
exactly, ma'am.
Okay, so
this is exactly what I'm planning to do, ma'am.
Okay.
I'm going to collect the field, the existing data, and I'm going to make that as, I'm going to take the average and make that as my base case. Then I'm going to use the software to iterate and simulate to see what happens for upper floors, and then I can determine whether there is relationship or not.
Okay, so that query is resolved. Now, if you are going for simulation, what are you using as weather data? You using EPW files?
Yes, ma'am. I'm going to use EPW file provided from Climate Consultant software, ma'am.
Right. No, you can download EPW file from Energy Plus website too. So that's not a problem. But does the weather data take into account the height?
No, it does not take into account the height. It is my work to correlate at what height did I get this data, at what height did I get this data. I will be the one to take that into account.
No, so I have a concern there, Kosi. I'm just communicating the concerns that I have. See, when we will simulate, suppose you have a base case, okay? So you will be finalizing the construction, the envelope materials and all that, right? And then you will be simulating the same building with different number of floors. So some case will have 10, 12, 15, 20, 25, whatever your range is, okay? Now, if you use the same climatic data, okay, if you use any simulation software, like some of them which I know of, they do not vary the outdoor environmental condition, the weather condition, for the change in height. So the indoor environmental conditions are going to be a result of the outdoor weather data and the envelope, building envelope, which is in between them, and the usage indoor. Now usage, you are fixing because the base case is fixed. The outdoor condition is also fixed and your building envelope is also fixed. What do you think will bring in the change when you vary the height? I don't see a parameter here which will actually bring in that change when you go in for simulations.
I think when I collect the data from, this is what I think, but it's, I'm open to your guidance as well. I think that the data collected regarding these thermal comfort parameters at the different, remember I'm taking them from different floor levels, and I'm making actual tables to show what was recorded at floor this, what was recorded at floor that, what was recorded at floor that. So even before or even without going to the simulation software, I can already see what is going on in the table according to the different heights. And I also have not pinpointed exactly what is the cause or what may be the cause for any differences that may come. And this is part of what will be found out in the field.
That is where my concern was, Kosi. Because when you are collecting the data on thermal comfort, it may be a result of several factors which may not be recorded or which may not be transferred into your simulation base case.
Yes, ma'am.
There may be a lot of these factors: usage, users, occupancy, the schedules,
Yes.
they will
Yes.
vary. Okay.
Yes.
Now, in order, and then you're saying that on each floor, you're going to collect this thermal comfort data, the indoor environmental, data.
Yes, ma'am.
So, which implies that each floor will have to have different schedules if you have to arrive at the same indoor environmental conditions.
Yes, ma'am.
When you go in to make a base case, you will have to generalize all that. I mean, have a common schedule.
Yes, ma'am.
Yeah. So now if you have the common schedule of activities, of occupancy, of usage, the building envelope is the same, the outdoor condition is the same. That is again the thing. While in actual, I'm not questioning that you will not get a different data when you go in for the survey. You will, most likely, you will get a difference in thermal comfort. Okay.
Yes, ma'am.
I agree with
Yes,
you.
ma'am.
But when you go for simulation, because you have to prove the variation through simulation, you will not be
Yes.
able to prove it otherwise. Now, if you have to
Yes.
go and prove that case in simulation, I am afraid
Yes, ma'am.
that there is not the varying height outdoor climatic data, like outdoor climatic data at varying heights to support your case.
I understand your concern, ma'am. And I think that if need be, I might have to collect additional data relating to outdoor conditions as the altitude increases, because the existing softwares do not provide this according to, does not consider altitude. It provides a generic weather data. But when I go to the field, I may have to, while collecting indoor weather conditions, I may have to also consider whether the wind pressure is increasing outside as I am going or higher, whether the temperature, solar heat gain is also increasing as I'm going higher. For the outdoor environment, I might have to collect that as well.
Yes, and that is going to be a tricky task, Kosi, because
yes,
one weather data, weather station itself, costs also, and you need to record. And then whatever weather data you are going to collect for the outdoor conditions at different levels will also have to be done simultaneously.
Yes, ma'am.
It has to be a simultaneous recording at each level. So I don't know if it is practically possible, but I just wanted to convey to you my concern. Otherwise, overall, I really think that, this is a promising work that you want to do. But I would still, I have expressed my concern over the methodology that you want to take forward. And, it might, from survey to simulation and to the final finding, I still see some missing links. You will have to see all the parameters that go in at each stage and then fulfill them, try to identify them and see for each of the parameters, how do you collect the data? Otherwise, there will be a lot of assumptions. You might still go ahead with a lot of assumptions, but the more you have the assumptions in your research, the less authentic and the less useful the research becomes.
Yes, ma'am. I understand this, ma'am.
So that was it from my side, but overall it was a good work. You just need to resolve a couple of these issues. Thank you.
Yes, ma'am. Thank you very much, ma'am. I'll discuss this with my guides, and we will choose the right methodology, ma'am.